Hello, and thank you for taking the time to review this demonstration of ASV, the Automated Signature Verification Solution from CDIT. In this short session, I'll provide an overview of the solution and demonstrate how it can be applied to the verification of signatures captured on returned postal ballot envelopes. For context, CDIT is a business process automation specialist with over 30 years of experience delivering intelligent automation solutions built on tungsten automation technologies. We support customers across government, financial services, logistics, utilities, and pension administration. Automated signature verification has been part of our portfolio since 2012 and continues to be used in high-volume operational environments today. Before discussing the signature verification process itself, it's worth briefly highlighting the platform upon which the solution is built. Tungsten automation is recognized by Gartner, IDC, Everest Group, GigaOM, and other industry analysts as a leader in intelligent document processing and automation. This provides a proven enterprise foundation that is already being used by governments, financial institutions, and large organizations around the world. The proposed solution is built on Tungsten Total Agility, which serves as the operational platform for the end-to-end process. Total Agility is responsible for receiving scanned envelopes, extracting QR codes and signatures, retrieving reference signatures, invoking the ASV engine, routing work, supporting adjudication activities, and maintaining a complete audit trail of all processing decisions. In addition to signature verification, the platform provides the workflow, reporting, security, and integration capabilities required to support a production-scale election process. This means the signature verification capability is not operating as a standalone tool, but rather as part of a complete business process that can scale to support large processing volumes. This diagram illustrates our understanding of the proposed election process. Postal voting introduces a unique operational challenge. On counting day, election officials may be required to process thousands, or potentially tens of thousands, of returned ballot envelopes within a very limited time frame. Each envelope contains a wet ink signature that must be verified against a previously captured reference signature to help confirm the identity of the voter. Performing this comparison manually is labor-intensive, subjective, and difficult to scale, particularly when operating under strict processing deadlines. At the same time, the process must balance two competing objectives: minimizing the risk of accepting a signature that does not belong to the voter, while also minimizing the volume of ballots requiring manual review. The proposed solution addresses this challenge by automating the extraction, retrieval, and comparison of signatures, allowing election officials to focus their attention on only those cases that genuinely require adjudication. The process begins during voter registration, where a wet ink signature is captured and associated with a unique voter identifier. A QR code is generated and linked to that voter record. On counting day, returned envelopes are scanned. The QR code is used to locate the reference signature, and the signature on the envelope is extracted and compared against the stored reference. The solution generates a confidence score which drives the downstream workflow, including automatic acceptance, automatic rejection, or manual adjudication where appropriate. Signature verification is fundamentally a balancing exercise. The goal is to maximize the number of genuine signatures that are accepted while minimizing the number of fraudulent signatures that are incorrectly approved. A true positive occurs when a genuine signature is correctly accepted. A true negative occurs when a non-matching signature is correctly rejected. False positives and false negatives represent undesirable outcomes and are managed through threshold tuning and manual adjudication. Every deployment requires a balance between automation rates and operational risk. In fact, just now I ran a test on a small sample of signatures to demonstrate its performance. We evaluated ASV against another commercially available signature verification engine using 703 signature comparison pairs derived from 38 signatures belonging to 8 unique signers. Across the dataset, ASV achieved an overall accuracy of 93.5% and recorded a false positive rate of 0%. From an election perspective, The false positive rate is particularly important because it measures the likelihood of incorrectly accepting a signature that does not belong to the registered voter. While every deployment requires threshold tuning and validation against production samples, these results demonstrate the underlying capability and maturity of the technology. The confidence threshold directly influences both automation rates and adjudication volumes. A lower threshold will increase straight-through processing, but may introduce greater acceptance risk. A higher threshold will reduce acceptance risk, but increase the number of signatures requiring manual review. For example, if 20,000 envelopes are processed and the threshold configuration results in a 5% exception rate, approximately 1,000 signatures would require adjudication. If the threshold is tightened and the exception rate rises to 15%, approximately 3,000 signatures would require review. This balance is typically established during testing and tuning activities. Okay, let's dive into a little demonstration. What we're looking at here is the total agility work queue. In a production election environment, this queue would contain those signatures that require manual adjudication. As ballot envelopes are scanned and processed, the vast majority may be handled automatically based on configured confidence thresholds. However, any signatures that fall within an uncertainty range can be routed to election officials for review. Multiple users can monitor this queue simultaneously, allowing adjudication activities to be distributed across a team during the counting period. Let's open the first item in the queue. The adjudication screen has been designed to present all of the information required to make a decision on a single page. In the upper left, we have metadata relating to the document, the extracted signature, and the associated voter record. In the center left, we have the transactional signature that was extracted from the returned ballot envelope. Below that, we have the reference signature retrieved from the reference signature database. In this demonstration, there is a one-to-one relationship, meaning a single reference signature is associated with the voter. On the right-hand side, we have the document viewer, which displays the original scanned envelope. The signature field has been highlighted, allowing the adjudicator to quickly locate the signature within the context of the document. The document viewer includes a range of navigation tools, allowing users to zoom, pan, and inspect the image in greater detail where required. In this example, the system has already performed the comparison and generated a confidence score. Although the computed result indicates a match, this example has been configured to require manual adjudication so that we can demonstrate the review process. The adjudicator can compare the extracted signature against the stored reference signature and make an informed decision. Having reviewed the evidence, the adjudicator determines that the signatures belong to the same individual and approves the item. The decision is recorded and the workflow progresses automatically. Upon completion, the user is returned to the work queue and can immediately begin working on the next available item. Let's look at a second example. Once again, the screen presents the extracted transactional signature, the reference signature, supporting metadata, and the original document image. The adjudicator can zoom and navigate through the document as required to examine the signature more closely. In this case, the comparison result is significantly lower. The system has identified this signature as uncertain and has routed it for manual review. After comparing the transactional signature against the reference signature, the adjudicator determines that the signatures do not sufficiently match and therefore rejects the item. The rejection decision is recorded and the workflow proceeds accordingly. Before we move on, I'd like to briefly show a few additional examples processed by the solution. Each example shown here represents a different voter and a different signature comparison result. In this example, the transactional signature and reference signature are highly consistent. The solution generated a confidence score of 79 and classified the comparison as a match. This example also produced a match result with a confidence score of 79. Despite variations in stroke length and positioning, the underlying signature characteristics remain consistent. Here we see a more challenging signature style with overlapping strokes and greater complexity. The solution generated a lower confidence score of 55 and classified the result as uncertain, making it a candidate for manual review. In this example, the confidence score was 68. While there are similarities between the transactional and reference signatures, the score falls within an uncertainty range and would typically be presented to an adjudicator for a final decision. Finally, this example produced a confidence score of 82 and was classified as a match. The solution was able to identify strong similarities despite normal variations that naturally occur between signatures captured at different points in time. Before concluding, I'd like to leave you with a couple of conceptual examples that demonstrate the flexibility of the platform. What you've seen so far has been a functional proof of concept designed to validate the signature verification capability. The user interface itself should not be viewed as a final design. Total Agility is an application platform, which means the user experience, workflow, and business rules can be adapted to meet operational requirements. In this example, we've simplified the adjudication experience considerably. Rather than presenting users with a work queue, the system could automatically deliver the next signature requiring review as soon as a decision is made. This approach may be appropriate in scenarios where operators are dedicated exclusively to adjudication activities and throughput is the primary objective. The operator simply reviews the evidence and selects Approve, Reject, or Unsure, after which the next item is automatically presented. The workflow itself is equally configurable. For example, a signature could require review by multiple adjudicators before a final decision is made, or disagreements could automatically be escalated to a supervisor or secondary review queue. These are operational decisions that can be incorporated into the workflow based on the requirements of the election process. This second example illustrates how the information presented to users can also be adapted. Some organizations may prefer to display the original document and surrounding context, while others may prefer a simpler interface focused exclusively on the transactional and reference signatures. Additional information can be introduced where required, or unnecessary information can be removed to streamline decision-making. The objective is to present operators with exactly the information they need to perform their role efficiently and consistently. The key takeaway is that the signature verification engine and the business workflow are independent components. The underlying verification technology remains the same, while the user experience, workflow rules, routing logic, escalation paths, audit requirements, and operational processes can all be configured to align with the specific needs of the organization. In summary, the proposed solution combines automated signature verification and tungsten total agility to provide a scalable, auditable, and configurable platform for the verification of postal ballot signatures. The solution supports document intake, QR code identification, signature extraction, reference signature retrieval, automated comparison, workflow orchestration, reporting, and manual adjudication where required. It can be deployed on premises, within a private cloud, or within a government-controlled cloud environment such as GCC. Most importantly, the solution can be tailored to balance acceptance risk, manual review volumes, operational capacity, and election-specific business rules, while maintaining a complete audit trail of every decision made throughout the process. Thank you for your time and consideration. We appreciate the opportunity to present the solution and look forward to discussing the next steps.